Hello, it is a nice sunny day. It's about 12:40 in the afternoon, local standard time, and it's been pretty sunny for most of the day. So let's talk performance. Here we have our solar regulator. You can see that the green light means that it is set up. The blue flashing light means that we do not have a Bluetooth connection. And on the end, you see the red and yellow lights flash from time to time. Red means that it is sending a request to one of the microinverters up on the roof, and yellow means that it is receiving something back. There is a light in the center right about there that will light up when the solar regulator is actually talking to the app. Now, what we're going to do is we're going to look at the app data, and you're going to get to see the app in action quite a bit, and we'll see how that's going to perform. So if we go ahead and run the app, you can see that we have that. It's still blinking blue, but when I click connect here, you can see that hopefully that will, okay, that just changed to solid, and the light in the center tells us that it was actually talking to the app. And the app is now asking for the passcode that we use. And I have punched that in now, and we hit submit. And as the app often does, it asks if I want to sync my historical data. I would guesstimate that probably about 20% of the time that I run the app, it actually asks me this. But let's go ahead and tell it yes, because that's going to be important for what we're doing. So it's a nice sunny day. It's been sunny most of the day. Let's see what the app tells us, assuming that it actually goes ahead and works. Okay, there we go. You can see, hold on just a second. You can see that it thinks that it's nice and sunny today. It thinks that we have 1% cloud cover. You can tell from the production here, the units over here, we're going up to 100 watts per hour. Generally speaking, you can see that the current production is 0, but you can see that my home consumption is very low. And so whenever the home consumption drops below a certain point, my suspicion is that the solar regulator chooses to not pump power back in to prevent going negative. But this is a relatively normal home usage for us during the day when no one is here. I am going to pause this video briefly and go and turn on some loads just to get that number up a little bit so that it makes things a little bit more interesting. I'll be back in a second. Okay, I am back, and I have turned on some additional load. So you can see that we've got the blue light there. We hit submit. And okay, now you can see that we are using a little over 2 kilowatts. Current production is not much, 29, and then we're doing 100 watts on the battery. You can see that now we have produced 791 watt hours, and you can see that for the 0.8 kilowatts, it's showing an energy value of 20 cents, which means that we need to go into setup because the app has a bit of a bug, and we need to make it actually recognize this cost per kilowatt hour of 12 cents, and we do that by pressing there, hitting save, and now sure enough it is showing the right thing. If we click on more and about, you can see that this is version 3.13 of the app. Okay, so let's look at what we got going on here. The way that the app reports information, it basically shows a portion here at the beginning that is actually battery power that's going into the inverters up until around the time that daylight hits, and then you'll have a peak in the center that'll drop down to 0, and then it'll come back up again showing what the battery usage is. But before we get into that, though, I want to look at what each one of the inverters and battery commanders is doing. So I suspect that all of the ones with the battery converters are going to be in the mode of solar to battery, so they are not actually providing any power right now to offset the grid usage. You can see that right now they are charging with 47 watts, 29 watts, 20, 16, 14, and then for the final one, this is only an inverter. It does not have the battery commander. The inverter is currently producing 0 watts. It seems kind of low, but you know that's what it's showing anyway. And you can see that it's nice and sunny out right now with nary a cloud in the sky. So let's go here to the production tab, and you can see that for the production tab it's showing that we're currently producing 38 watts, and it's showing that today's peak is 465 watts. That number is not terribly useful though, because that number is actually the peak that is going to the inverters. That does not mean it's the peak going to the inverters from the solar panels. It could very well be coming from the batteries. So the only thing that tells you is the overall peak. It doesn't give you any indication of how much you're actually getting from the solar panels. I have 6 sets of solar panels, so technically I should be able to produce 1.8 kilowatts theoretical max from just the solar panels, but we don't know what this number's from. That could actually be from a certain period of time over here when the batteries were actually charging or when the batteries were feeding the inverters. We just don't know. But anyway, you can see that the total produced, according to this, is a little over a third of a kilowatt. Now what I have here is I actually have historic data from what the weather has been like. And this historic data, it's not super fine granularity, but you can see that for any given day, for the 6 a.m., that covers the time period from 6 to noon, and then we can see here that we have passing clouds, and if we look at that one, you can see that it's sunny, and that's on October 17th. Same thing here, you can see we've got sunny and sunny. So what we can do, I'm going to go ahead and set this on the current month, and if we look at this data, we can only get as far forward as November 5th. It's currently on the 7th, but let's look at what we got going on here. So here are the 3 humps I was talking about. You've got the battery hump right after midnight from 0 to 6 a.m. Then you've got the hump in the center, which is actual solar production. And then you've got the hump over here at the end, which is battery. Now, it wouldn't have to be this way. You know, it could be that some of this is actually being produced by the battery also, but that does not appear to be how the solar regulator works. You could see from before that everything that has a battery commander is actually charging the battery right now, because I think that the solar regulator tries its hardest to make sure that the batteries are charged at the end of the Sunday. So even though we're using a lot of power right now, and we could easily be pushing everything in to offset our power usage, that's not the way the solar regulator works. The solar regulator seems to prioritize charging the batteries, which is that's the decision that they make. So anyway, if we go back, so that's on the 6th. If we look on the 5th, again on the 5th we're showing sun and sun. You can see here on the peak in the center, these numbers over here, the scale on the y-axis is kind of useful just for getting a relative idea. of how much is being produced. For here in the center, we're up 210, 240 watts per hour. And that's actually pretty high compared to what you're going to see. If we look back on the 4th, the 3rd, the 2nd, the 1st, you can see that we've got sun and clouds. Here we've got clouds and sun, and then sun. So it's kind of hit or miss. So on the 4th, these in the center, we're down around 40. On the 3rd, we're in the 60 to 80. And on the 2nd, we're actually up around 150. So that's what we got on the 2nd. And then on the 1st, it should be more sun, so you would expect it to be a little bit better. But that's not really what we're seeing. And if you look at the time right before that, there's 0. So that tells me that the batteries have been fully depleted from the previous day's sun production. And so that's on the 1st. So if we go back to the 31st of October, if we look at what was happening on the 31st, sure enough, we've got a whole lot of rain. And so the 31st was not a very good day as far as energy production goes. And sure enough, if we look at it on the 31st, boom, we've got this peak right here, but look at the units. This is literally 12 watts per hour production. And so we're producing virtually nothing. It drops off to 0 because we have nothing stored in the batteries. Same thing from the day before. We didn't have anything. On the 30th, you can see that it wasn't real good. And look at what happened here. The units are around 20, so we were producing something right there. And then at the 6 o'clock hour, we depleted the entire battery bank in 1 hour, and that got us up here to 160. And so that's where that's at. Interesting thing to note, these numbers up here are current. They have nothing to do with what you're seeing down here. So just be aware of that. And honestly, I'm going to look through the rest of these just so that you can see the numbers, the energy produced. Again, though, I want to point out that this 953 that you're seeing here for the energy produced is not really an accurate representation of how much solar we collected on 10/29. It is how much energy comes from the entire day. And everything that you're seeing here before around 6 or 7 a.m. is actually energy that was stored in the batteries from the previous day's solar production. And so this number has, it's just difficult to really figure out what it means if you're looking at trying to figure anything out on the granularity of one day at a time. So on the 28th, we're at 1702, 1910, 600. So that's just really bad. 1880, 1927, 2900, 2100, 1800, 2200. And the couple of weeks that this is covering, it does seem like it's been excuse me, cloudy a lot. And so I have not been expecting perfection, but this is from 6 sets of solar panels, where the other video that I had produced showing this information was actually from 2 sets of solar panels. So you would expect these numbers to be 3 times as much, and I just don't think that's what we're seeing. So if we click on this month's data, this might actually be more useful, since we've looked at it already by day. You can see that in October it just starts off and then it just really drops down to almost nothing. And in November, you can see that I'd say that we're probably averaging around 2,000. I mean, you can see that we're at 14 kilowatts. And so from our excuse me, from our current usage and what we pay for energy, that is how much that it is saying that we've saved this month. Obviously, we want those numbers to be better. I do have the most recent energy bill, and the most recent energy data indicates that this past month was one of our low usage months for the last couple of years. But it's hard to say if that's just because we are just getting lucky or how much the solar had to do with that. But hopefully this is helpful for someone, and more videos will follow. So if you haven't clicked subscribe, be sure to do so, and give us a thumbs up. Thank you much.